Hi, in this lab we're going to explore some scripts, how they are very useful using them in a legitimate way, and how they are actually used by malicious actors. We go to Model 8, lab number 1, and the legitimate script. Let's begin. Okay, so here we have a BAT file which is going to be executed by the Windows command prompt. We can click the search bar and type cmd and click this option. And here we are at the Windows command prompt. Here we have the path of our current directory. This is very similar to using the file explorer. We can click this PC, local disk, users, defender or current user, and here we are at the same path, C users defender. Let's go back to our terminal. Okay, in this terminal we have available a set of predefined actions or commands that we can execute. We can copy files, rename them, move them. We also can create directories, navigate between them, and see what's inside, and of course call on other programs. The command prompt also has a powerful feature, which is environment variables, because they can store data that programs can use later. And we have a command called echo, used to display text on the screen, and we can also use it to print the content of those variables. Let's say we want to print the environment variable user profile, so we type echo user profile. The name must be enclosed in 2 % signs, and that's it. We hit enter, and that's the content of the variable C users defender. That's the main directory of the current user. Okay, let's go back to our legitimate script. This will create a backup of all the files in the documents folder, save them in a separate folder, check for files older than 7 days, and delete them. Okay, the first instruction is setting some variables like month, day, year, hour, minutes, and daytime. It's using the keyword set, the name of the variable, an equal sign, and the content of the variable. We can see it's using an environment variable date and this notation. This notation is used to extract substrings from the variable. Let's test it out in the command prompt. Let's say we want to print date. This of course is current date, but we can extract a substring. The first number is indicating the index, and the second number is indicating the length of the substring. The substrings are indexed by 0, so the first character is 0 and so on. So let's see. We want to extract the substring beginning at index 4. So this is index 0, 1, 2, 3, and 4. So the month substring is starting at this character and it's taking 2 characters. So it's 05. Okay. The same goes with day, but now it's taking the 7th index. This is 4, 5, 6, and 7. Great. And for year, of course, 8, 9, and 10. And it's taking 4 characters. Right. And something very similar happens with the time variable. Sorry, echo time. starting from index 0 and taking 2, and then starting from index 3 and taking 2 again for hour and minutes. And finally is defining a new variable datetime with this format: month, single dash, day, single dash, year, underscore, hour, single dash, minutes. And okay, that will be just a simple date format. We can of course copy all this and execute it in our prompt and reveal the content of this variable. Great. Okay, next step. We have to set up the source of the files that we want to copy and the destination and a log file. Okay, so the source is going to be the main directory of current user, folder documents. Destination will be again in main directory, backups, documents, and we use this datetime to know when the backup was created. And a log file just to have a log of what we did. Okay, we can see the echo command just to bring some stuff to the screen. Here we have this instruction: if not exists the source directory, well, that will be an error because we don't know what we have to copy. So we report that error and go to the end of the screen with this command go to, and we specify the tag end, which is right here. Okay, in the case the source directory exists, we continue and check if the destination directory does not exist. If not exist destination, we simply create it because it doesn't matter. We can just create it. And we start copying the files. We use the command xcopy. We specify the source of the files and the destination. Now we are checking this variable error level. This is a special variable because it can tell us if the previous command had an error. In this case, if the error level variable is not 0, is not equal to 0, it means there was an error. So we report it and we continue. In case the error level variable is actually 0, we know the command completed successfully. And now we go to the step of cleaning older backups. So we again use another command for files and explore all the folders in this directory and checking those that are older than 7 days and delete them. And again we reach the end tag that now just writes to the log that the backup process it's finished and we are done. Now we have a PowerShell script, a malicious PowerShell script. PowerShell is like a modern version of CMD with more capabilities, but the main idea stays the same. We have some set of actions or commands. We can define variables and use conditional execution, these if statements. It's important to note that both CMD and PowerShell can be used for legitimate reasons, but also both of them can be used for malicious purpose. We are only switching to PowerShell to show another type of scripts. Okay, here the attacker is defining a new function, some sort of new command that can be used later in the program. It's called test registry value. It's receiving parameters just like the xcopy command before. It's testing the path of the registry and simply checking if the value exists. Okay, but we can come back later. Now here comes the real instructions. Okay, here the script is setting persistence. It's defining a variable, the rec key, and it's getting the value of each KCU, software, Microsoft, Windows, current version, and run. And a value name of Hack Defender PS1, and the current script path. This simply gets the path of the current script. Okay, and checks if that registry value exists. If it does not exist, then we just set that value. But what is this Windows registry? We can again click the search bar, write registry editor right here. This requires admin permissions. And okay, HKCU stands for HKey current user. Now we navigate to software. This is very similar to folders. Microsoft, Windows, current version, and run. Great. Okay. Now, what is so special this registry? Well, when the Windows machine is powered on, it goes to this registry and checks all the values defined, and we can see those values have a string that is actually a path of an executable. When Windows machine is powered on, it goes and executes everything that's defined here. So the script is actually setting persistence. He is defining that when Windows machine is powered on, it must execute the malicious PowerShell script. Okay, so that's what's happening here. We can close this. And let's move on. Okay, next step for this malicious script is exfiltrate data. Let's say the malicious actor iterates over every docx file in the documents folder, and using this keyword for each iterates over every file in or variable files. It gets the content and defines a URL. That is the website, the server of the malicious actor. And it's defining the HTTP requests to be sent. Using a post request to the malicious server and exfiltrating those documents. Of course, the script can also download a next stage. This invoke REST method is used to send data, and invoke web requests could be more like downloading other data. And with invoke expression, we're going to execute all the PowerShell instructions defined in the parameter, which is the response to the HTTP request. And here's where the script becomes so dangerous, because now can execute whatever the attacker wants. Let's say he wants to execute some ransomware. So this next stage could easily return the content of this ransom PowerShell script. Of course, this is not a real ransomware script. This is simply demonstrating how the script could be, setting a ransom node, iterating over the documents folder, and in this case simply rename the files, not encrypt them. but a real attacker could encrypt our files. In real life, it's very unlikely to find scripts like this, small, using descriptive names, and with clear strings. The common situation is to find obfuscated scripts. In the next 3 labs, we'll explore some obfuscation techniques in BAT, PowerShell, and JavaScript.